Good afternoon, everyone.
Good afternoon.
Today we are going to discuss about the case study video on the topic real-time applications in KVL and KCL. So before entering into the topic, the first thing we have to know what do you mean by KVL and KCL. So what is a circuit?
A circuit is a part where electric current flows through n number of electrical components like resistor, inductor, capacitor.
So what do you mean by current?
Current is the flow of electrons known as current.
So these are all the basic concepts, we already know that. So we have to know the basic things in the KVL and KCL. So suppose if we are using any of the circuits, any of the home appliances, whatever it may be, suppose if we are using a battery, we have to charge that. So everywhere electronics and electricals is available. So the most consideration and the important thing is KVL and KCL. Can anyone explain about what do you mean by KVL and KCL?
Good morning. So we are students of Department of EC. Today we are going to discuss a case study on the topic Kirchhoff's voltage law and Kirchhoff's current law on the basis of a solar powered house system. So Kirchhoff's voltage law and Kirchhoff's current law are the basic and fundamental rules in electricals and electronics engineering to analyze a circuit law. Kirchhoff's voltage law, also known as KVL, is the total sum of total voltage across a closed tube is equal to 0. It obeys the law of conservation of energy, which is the supplied energy is completely used within the circuit system. On the other hand, Kirchhoff's current law, also known as KCL, it states that the total number of current entering into a junction or a node is equal to the total number of current leaving the junction or node. It obeys the law of conservation of charge, that is, no electric charge is neither created nor be destroyed. So these two rules are most used and widely used among the electrical and electronics engineering.
Can we relate that with real-time examples?
Now we will see a real-life example. Solar powered houses. In this system, 24 volt solar panel is used and battery charge controllers and electrical appliances like fan, light, water pumper. The solar panel provides electrical energy that sends current to the distribution junctions. The junctions divides the currents and promote the current to all the appliances. In the junction demonstrate the KCL and the complete circuit loop demonstrate the KVL.
Electricity generated in a power plant is sent to the substation and then it was sent to the cities, industries and the villages. The current entering behind one node distributed point is equal to the LED leak. If there are any leakages, the KCL will ensure that.
The KVL concept by a battery system. Think about an inverter or a solar power setup in a house. The battery provides the electrical energy, and this electrical energy travels through the wires and is used by the appliances. As current flows through these wires and devices, energy is gradually used up. So at the end of the loop, the energy supplied by the battery is used by the components or the electrical appliances at the end of the wire. So I conclude that the energy remains unused. It does not disappear suddenly. It is actually used by the electrical components in the circuit. The balance energy is known as Kirchhoff's voltage law.
So just you got an idea about where the KVL and KCL has been used. Now can anyone conclude these topics?
As we saw a real world example of solar power houses, we can confidently say that Kirchhoff's law is not just a theoretical concept. From this case study, we understand that KCL ensures electrical current distribution throughout the circuit, and KVL ensures that a balanced current in the circuit. These laws are used in household wiring and solar systems and electrical cars and electrical circuits. This Kirchhoff law is the backbone of, we can say, the backbone of electrical and electronic engineering analysis. Thank you.
Thank you.
Thank you.
Thank you.